fraction? Well, we know it's 3 over 1. We know the negative sign has nothing to do with the 3. The exponent is only on the 3. So I'm going to rewrite this as negative 1 times 3 over 1 power negative x. If I write it like this now, the negative 1 stays on top. The 3 gets flipped. Okay, oh, sorry. The 3 becomes 1 over 3 power of x. And now you can see, hopefully, that my b value is not 3, it's 1 over 3. So does everyone see that my b value is actually 1 over 3? And that makes sense, because if my b value was 3, you'd see my values going up by 3. It would be timesing by 3. Remember, my growth factor is the amount that it's growing by, right? And we just did a few values, so you should have been, been like thinking, oh wait, hold on. My values are going down. They're not going up by 3s. Like, they're not going 9, 27, 81. No, that's not true. It's going 9, 3, 1. It's actually going down by 3. So my b value could not have been 3. This is not a growing function. This is a decaying function. So my growth factor, or rather my decay factor, is 1 over 3. So my b value is 1 over 3. So just be careful with that. Anyway, so yes, you guys gotta pay attention, think when you're in class. So here we have our table of values. They're completed. Negative 2 and negative 9. Right. So negative 9 and negative 2. Negative 1 and negative 3, 1, 2, 3. 0 and negative 1, so that's here. 1 and 1 over 3. No, sorry, negative 1 over 3, so that's like halfway roughly, and negative, that's like that. And that is going to go like this. And I recommend always drawing a dotted line wherever your asymptotes are, just to show very clearly where the asymptotes are. Otherwise, you may lose a mark when it comes to graphing. Actually, you will lose a mark when it comes to graphing, because if you're not showing that dotted line, that means you don't know whether there's asymptote or not. Like, you're not showing me that you know there's asymptote or not. So you have to show this dotted line. Otherwise, you're going to lose marks. All right, so we've graphed it. What's the domain? Pretty straightforward. The domain is XCR. What's the range? In this case, the function is at the bottom here. So it's YER such that y has to be less than 0. Because the function is below y0, right? Like, it's not above here. It's below. X-intercept, once again, there is no x-intercept, not applicable. Y-intercept, once again, y-intercept is very simple. Just plug in x equals 0, which we literally do almost every single time. So y is negative 1. That is y-intercept. Now, is this increasing or decreasing? This function, remember, you're always reading from left to right. So it's going up. It's actually always going up. So always increasing, always increasing. And asymptote, well, there's a horizontal asymptote of y equals 0. Now, is there always a horizontal asymptote of y equals 0? And the answer is no. When we get into transformations, which is going to be literally the next thing that I do, you will learn that the asymptote depends on your c value. And we'll get into an example of that. But for now, since my c value is actually 0, how do I know my c value is 0? Well, remember, c value is always the constant that's being added or subtracted at the end of a function. So usually it's like plus 9 or plus 3 or whatever, minus 3, 2, whatever. So that's your c value here. Clearly, there's no c value, so 0. So my asymptote is y equals 0. So let's do this. What's this? Oh, this is a bit tricky, but I'm going to do this one. This is a good example. We need to do at least one example of this. See, we need to do a lot. Damn. Okay, doesn't matter. We're going to do as much as we can. All right. this specific question I've done many times with my class. It's a little bit hard because you have to look for points on the graph. It's a bit hard to see points on the graph, so I'm going to give you the points. And was it this one or this one? I always forget. I think it's that one. And then this one right here. Okay, so we got 3 points. You need at least 3 points. Otherwise, it's going to be very difficult to do this. So the first point is 1 and 6. Next point is 2 and 18. And the third point is 3 and 54. Now, normally on a test or a quiz, you will be given a graph that is very easy to find the points. Like, it'll be very, either the points will be given or it'll be very, very easy. Like, you'll be able to pick it out, like, pretty straightforward. Like, oh, it's clearly on the corner at that point. So here we have 1, 6, 2, 18, 3, 54. What do we do? Well, we know our equation is y equals a times b to the power of x, right? What's my b value? What's my growth factor? Well, I can figure that out by dividing the second value from the top value. So what's 18 divided by 6? It is 3. And 54 divided by 18, it is also 3. So my b value is 3. That's my growth factor. What's my a value? What's my initial value? Well, we can figure this out. I know my x value is 1, and my y value is 6. So I can plug that into this equation here. So y is 6. 6 is equal to a times 3 to the power of 1. So all I did was I took a point and I substituted it into my equation to solve for my a value. And it's not the first time we're doing this. It's not going to be the last time we're doing this. To solve for a, you always have to sub in a point into your x and y values and then use algebra to figure it out. So 6 is equal to 3 times a, divide both sides by 3. And that's 2 is equal to a, or a is equal to 2. So since I know that a is equal to 2, b is equal to 3, guess what? I have my equation now. It's 2 times 3 to the power of x. Okay. So now we got A, we got B. What's the question asking? What's the question asking? Oh, that's it. We're done. Final equation. Was that it? Did we finish it? Oh yeah, we're done. Yeah. Okay, yeah, we're done. That was it. We got the equation. Ooh. All right. Let's move on. I should do example 4. I'm just gonna talk about example 4. I'm gonna do it. This is something that you guys should definitely know. So here's example 4. We have to move on to the other units, man. Okay, listen carefully. So when we have our equation y equals a times b to the power of x, right? A is greater than 0, meaning this a value is bigger than 0, so it's like positive. And b is greater than 1, meaning it's growth, so it's a positive growth. So a positive exponential function, growth function, looks like this. So it's always increasing, because it's always, going up, it's increasing. All right, what if we have same thing, where my a value is still positive, but now my b value is between 0 and 1. That means it's a decay. That means it's a decay. It's decreasing. So it's always decreasing. That's what it looks like. Now let's flip